Okay, very last question, the skydiver one. This is one I kind of screwed up on. I showed in class, I showed a way that I could kind of fix it, but let me make it more correct here. It says two skydivers are falling. We've got one in free fall, and we have one who's in real air. And for the one in free fall, I've got velocity on this graph going from 0 to 70, and time going from 0 to 7, and acceleration from 0 to 11, and time there. What I should have done, let me show you what I said the answer was, but it's kind of iffy. So if I change this velocity to speed, then this is okay. This graph is okay. When a skydiver jumps out of a plane at time 0, they're not really falling yet. After 1 second, remember the acceleration of gravity, negative 10 meters per second squared. After 1 second, you're going to be pulled downward so that you're going negative 10 meters per second. And after 2 seconds, you're going to be pulled downward harder, so you're going to add another one of these on, or you're going to be going negative 20. And then after another second, you're going to be going negative 30. So you're speeding up, but you're going down, so it's not really velocity, because if it were velocity, this should be negative 10, negative 20, negative 30, negative 40, negative 50. So this is showing speed. And it's okay showing speed. After 1 second, you're going 10, 2 seconds, you're going 20, 3 seconds, you're going 30. So you're speeding up. Just got to remember that speed is downward speed. This is not so good. I've said that the acceleration is 10, and I can't really fix that by crossing it out and writing speed. There's nothing like that in terms of acceleration. This should really be negative 10. That's the acceleration of the skydiver the whole time, if they're in free fall, if there's no air. So if I were to do this again, the first graph would look like this. I'd have 0, this would be the velocity, and it would go negative 1, negative 2, negative 3, negative 4, negative 5, 50. Negative 10, 20, 30, 40, 50, negative 60, negative 70. 1 second, 2, 3, 4, 5 seconds, 6, 7, 8, 9, 10 seconds. So it'd be going like this. Every second, you'd go 10 meters per second. Ooh, slower? Speed would be 10 meters per second faster, but your velocity would be 10 meters per second more negative. So you'd be going 10 meters per second downward, 20 meters per second downward, 30 meters per second, 40, 50 meters per second downward. That's all that negative means, is downward velocity. And the acceleration graph, this would be 0 acceleration, acceleration in meters per second squared, 1, 2, 3, 4, 5 meters per second squared, 6, 7, 8, 9, 10. Oops, screwed it up again. I got to make that negative. So there's my acceleration graph. It stays negative 10 the whole way. That's really the right way to do it. And this is time. 1, 2, 3, 4, 5 seconds, 6, 7, 8, 9, 10 seconds. So that would be good. This, like I said before, if this is on the test, it's going to be some kind of a bonus. What I did is I had screwed this up originally. I changed this to make the scale more correct. Made the scale more correct again. Should make that speed. It's got the same problems as you had up here. But what this is showing basically is that in real air, if you assume that somebody reaches terminal velocity, this is right. This is like 120 miles per hour. If you assume that somebody reaches that after falling for 12 seconds, then this is what their speed graph would look like. It's not a straight line. They're not going to have the same change in velocity or change in speed the whole time. They're going to start speeding up really fast at the beginning, and then their acceleration is going to decrease. They're going to speed up more slowly until after 12 seconds, they stop speeding up. Now they're at their terminal velocity of 120 miles per hour or 54 meters per second. So it's going to just curve until it's flat, and that's terminal velocity. on an acceleration graph, it'd look like this. Again, this should kind of be negative, so it really would be shaped like that also. It's kind of funky. But acceleration is 10 here, and then after a little while you're not accelerating as fast anymore, accelerating even slower until by the 12th second, acceleration is 0. There's no more acceleration. You're not speeding up downward. Let me just do this. Negative, negative, negative. This is like an upside down world where up is negative and down is positive. So you'd start out with negative 10 meters per second acceleration, and after 8 seconds maybe you'd be down to like negative 2 meters per second squared acceleration. I think I said meters. Let me fix that. Oh, Mr. Stapleton. This should say meters per second squared. Wrong units. So anyway, after 12 seconds, no acceleration whatsoever. That's terminal velocity is those last 2 seconds in both of them. Again, if this is on the test, it'll be a bonus.